Oh boy, this is going to be a fun one. So trigonometry test for grade 10. So this is the one that I came up with. Again, like all the tests I come up with. So you can go in the show notes below and you can download the PDF file for yourself and then give it a shot. And then once you do, you can come back here and then watch the rest of the video to see how the solutions go. So they'll start off rather easy, but I did put in certain things that I think that every grade 10 student should know, a student who kind of wants to be maybe a little bit step above to understand some just conceptual things as well. All right, so let's get started. So question number 1, this one is probably the easiest one of all of them. So it is just kind of deja vuing you on the idea of solving, okay, with sines, cosines, and tangents. So for example, so this question right here, so if you want to solve for theta, well, all we're going to do is we're going to take the inverse of the ratio, so 3/4, and then we're going to get our theta. So that answer is, okay, so let's do that. So sine inverse is 3/4, so that's 0.75. Let's put that in there. And again, so I'm just assuming that we're working with degrees. All right, so that is the angle theta, which is 48. Let's round it off to 1 decimal place. That would have been our first answer. All right, so here's the second one, so part B. So for part B right here, so we want to be able to solve for x. So we can multiply both sides by 10, and we're going to get x is equal to basically 10 multiplied by cos of 38 degrees equals. So let's take the calculator out. 10 multiplied by cos 38 equals, and that is, let's keep kind of 2 decimal places there, 7.88. All right, so that's the second one. And then the last one, so that's using the tangent. And now our x, our unknown, is in the denominator for that one. So basically I'm going to take x to the numerator, so multiplying both, or cross multiplication. So x ends up in the numerator, and then we're going to get 82 divided by the 10 of 65 degrees. Let's do that right here. Where's 82 divided by 10 of 65, and there we have it. So that's 38 point, again, I guess I'll just keep 2 decimal places. You can keep whatever you like. The question didn't state that. All right, so those were kind of question number 1 for us. So that's out of the way. Let's take a look at question number 2. So for question number 2, what is the meaning of, this is a good one for us. And so oftentimes what happens is these sines, cosines, and tangents, okay, so when you're initially learning it, people completely kind of forget that they have to do just with ratios. And they were done by just definition. So don't forget that if you have, so I'm going to actually draw, I'm going to do a little bit of a sketch here for you. So if you had a coordinate system, so if you have a coordinate system like this, let's say this was your x and your y. And, you know, from the origin, you create basically kind of a line that goes, you know, in a certain direction here. So these sines, cosines, and tangents are basically related to the creation of a triangle, okay, which has that, I guess, the pink line as its hypotenuse. So here you created a triangle. And now it relates back your angle that you have. So your angle, which is created right here. So it creates this particular angle. And it allows you to have that angle and define, for example, first, so the meaning of sine of that angle is really just equal to your opposite side. So whatever your length of the opposite side of that angle is, and divided by the hypotenuse. That's what your sine theta actually means. That's the meaning. So the meaning is the ratio between the two sides. The opposite and then the hypotenuse of a triangle. All right, so that's what that means. And it relates it back to any triangles that you like, as long as these triangles create a 90 degree. All right, so as long as we have a 90 degree angle right here. So as long as we have these 90 degree triangles, then this holds true. And that's the same thing for cos. So cos theta, the meaning simply means that now you're going to take the adjacent length, and that adjacent length, so this is the adjacent length divided by your hypotenuse. That is the definition of cosine. And then finally, your tangent of your angle is simply your opposite side divided by your adjacent side. So it relates back those two. So your 90 degrees is always right here, and then you can create whatever it is that you want, your sine ratio, your cosine ratio, or your tangent ratio. And so any triangle at all that you will ever create or you come across with that has a 90 degree, okay, somewhere within. And if you want to take, and for instance, if this was your theta, okay, so that means that this right here is your opposite of that theta. This right here is your adjacent, okay, which is directly attached to the theta. And then this is your hypotenuse. And if you want to know any ratio, so whatsoever, so if you take a ratio, O over H, it's going to define for us the relationship with that theta, and it's called sine. All right, and you can do the same thing for all. Okay, so that's question number 2, and that's the meaning. So the meaning is the ratios that are created between the lengths of sides, okay, and how they relate to your angle. Now, let's take a look at question number 3. What is the difference between similar and congruent triangles? So we have similar and congruent triangles. What is the difference? First, congruent triangles means that they are identical. So that's congruent triangles. So if you have a triangle 1 and then you are given another triangle 2, that means that if they're congruent, all their sides will be equivalent to each other, and then all the angles will be equivalent to each other as well. Now, they don't have to look the same. So for instance, you can have triangles. So let's say if this was my triangle right here, let's try to create one, just kind of like that. If I take this triangle, okay, and I duplicate it, so obviously these are congruent, they look identical. But oftentimes what happens is, you can start rotating these around. These are still the same triangles. These ones are congruent. It's just one has been rotated. But you can relate back all the angles and then all the sides, and you'll notice that they're the same. So that's congruency. When are two triangles similar? So the difference is that the sides are not going to be identical, but they're going to be proportional to each other. So what that means is that you can take these triangles, now you can scale them down or you can scale them up. The angles will not change. However, the sides will be proportional to each other. So whatever sides that we have, now they become proportional. So if this is, let's call this side A, for instance. This is side B, this is side C. So if we have that. Now, the way that this was kind of rotated, I'm going to call this A prime. All right, so I'll call this B prime, call this C prime. And what it means that this angle, this side divided by this side, that ratio between them is going to be equivalent to all the same ratios between the sides, and that is your scaling factor. So they're just proportional to each other. That's what similar means. They can be either bigger or smaller. The angles will all be the same. So angles, just like in congruent triangles, so the angles are the same, but the difference is that in similar triangles, the actual sides do not have to be the same, but they do have to be proportional to each other. So all of them are going to be proportional. So you can scale it up or scale it down. So that's another question. So this is a good one for you to think about and understand kind of the differences. Okay, so here's question number 4. So another good question right here. Let me copy this, bring it down. Let's try to work on this one. So for this, prove that triangle ABC is similar to triangle DBE. Point D and E are midpoints. So this really just tests your understanding of triangles, kind of midpoints. Now, how do I show that they're similar? So just as we mentioned, the angles have to be the same, right? So if we can show that the angles are the same, then they're similar. Or you will have that they are proportional to each other. So you can find that the sides are all proportional to each other. So you can show similar triangles in 2 different ways. One, either show that their angles are identical, or 2, you're going to show that the sides are all proportional to each other. So, are the sides maybe bigger or smaller? Okay, so depending on what you decide. Okay, so in this case, so I have this. It's telling me A, B, and C. So that's one triangle that I have. And then the other triangle, it says D, B, and E. All right, so now this D, B, and E, so I'm going to draw the triangle in there. Okay, so it's going to be kind of like this. All right, so let's see if we can draw a nice one here. So that's kind of more or less, that's the triangle that we want to be able to show, right? So let's do that. Okay, so it's about right there. So those are my 2 triangles. So I have a big triangle. So I have this A, B, and C like this. Okay, and then I have the smaller one, which kind of looks like that. So how are they similar to each other? Now I do know that D and E are midpoints. All right. So what that means is that these 2 are same, because midpoint means that they're split in half. And then this and this, okay, are the same as well. Okay, so I do know that. Now, if D and E are the midpoints, then this line that I have, so this connecting line of this triangle, what does it tell me about these 2 lines? Okay, because of the fact that D and E are midpoints, that means that these 2 must be parallel. So we know that from triangles and from midpoints. And if they're parallel, then that basically gives me all the information that I need. Why? Well, first of all, we do know that the 2 triangles share this angle. So clearly this angle is the same for both. Now, what I'm going to tell you is that this angle right here is the same as this angle right there. Why? Because what I have, I'm going to clean this up here. Okay, so I'm going to clean this entire thing up. Okay, so what I have is, I know that what I'm creating now, so I have this line, for instance, now this and this, okay, so those 2 are parallel. And what that means is if they're parallel, that means that these 2 angles are identical. And that is just from the properties of parallel lines that you have, okay, and because it creates an F. Now it's an inverted F, right? But we know that these two are the same. And I can do the same thing in reverse. So if I do this line going this way, that means that this angle and this angle will also be the same. Again, because of parallel lines. So, because I have this F pattern, except now my F pattern is in this way, and these two lines are parallel just as they were here. So that means all the angles are the same. If all the angles are the same, the two triangles are similar. So ABC is similar to triangle DBE. Okay. Now you could have also shown that by simply knowing and understanding that the sides were just scaled, right? So you know that the sides are actually scaled. So you know that this side right here, okay, and this side right here. So to go from here to here, okay, so the bigger one is basically twice as big as the smaller one, or the smaller one is this half. And that again just comes from the connection of midpoints, okay? So that's what you have there. And then the same thing happens here, and the same thing happens here. So the scaling between one and the other is actually a half, depending on if you're going to the smaller one, okay, or times 2 if you're going from the smaller one to the bigger one. So that's another way of showing it. But the angles were pretty easy. So that's question 4. So I hope that you, okay, were able to see that. Let's take a look here at question number 5. So for question 5, it says find the area of the triangle ABC in question 4 using the lengths of sides and angles of the triangle. Okay, so label the opposite sides of the angle, A as a small a, all right, and then so on. All right, so I'm going to copy this whole thing down. Now, okay, so area. So if I create this, and I have that. Well, what is area? Well, area of a triangle, we know that the area of a triangle is 1/2 base times height. So we know that. Well, here's our base. That's our base right here. And then our height, okay, it's going to be the height right here. I'm going to just drop a line right there. So that line is going to be a perpendicular line right there. All right, so that's this line. And that's my height h. Okay, and then this is my base b. All right, so that's what I have there. Now it is b already because it's the opposite angle, which is that. Now I guess these things, let me kind of remove them. I don't really need these two things in there. But what I do have is, okay, so that means this is, so sorry about that. So this is A. So that's the length of this side. So that's the length of this side right here. This length right here is C. So that's the length of that side right there. All right, so that's C. Now, if we want to know, okay, so the area is base times height. Well, the base is easy because it's already B here. And it's asking us to create the area of the triangle using the lengths and sides, lengths of the sides and then the angles of the triangle. So here is my angle A, here is my angle B, here's my angle C. Okay, so I'm going to just refer to these angles. So angle A, I'll just refer to it as just A. All right, I know it's the vertex, but it'll be just a little bit easier. And then, so on. I'm not going to need all of them. So what I really need is I need to know what this H is, right? But H, notice what it does is we have created, okay, so within here, so it creates kind of a perpendicular line, right? So with all of these. And I can relate that back, okay, so that H, okay, is, so I'm going to just draw this triangle right here. So I have that triangle there, okay, and this is, so I'm going to label, so this is C, let's call this point D there. So this is D and B. So that's my H. Now notice this is A, and then I know that this is the angle C. So what do I know about that angle? Well, A is my hypotenuse in this case of that right-angled triangle. So I know that the sine of the angle C, so of the angle C, is equal to, by definition, opposite, which is H, which is the height, divided by A. Okay, or if I, okay, so get rid of this A, multiply by both sides, I'm going to get H is equal to A times sine of the angle C. Okay, I'll just write it like this. And now I can substitute it in here, and I will find that my area is simply 1/2 base, okay, times A times sine of the angle C. And that would have been the area written out in terms of the lengths of the sides and then the angles. Now I only need one of them, so I can write this out as 1/2 A times B and then sine of C. So if I know that angle right here, and I know these two sides, I can find the area of that triangle, which is great. You can also write the area, okay, if you have chosen this right there. Okay, so if you know the angle A, so capital A, you can rewrite H, okay, as basically just, it's going to be using the side of the C, which is exactly what I did on this side, but you're going to do the identical thing there. So you can write it in two different ways. So that's question number 5. So it's definitely a thinking one because you aren't actually computing anything. Okay, question number 6. So another interesting one here. This one is actually with some numbers. So let's copy this down. So for this question number 6, what we have, here it is. All right, so I have that. You're given an isosceles triangle with a base of 10 centimeters and angle of 50 degrees. All right, so as illustrated right here. Okay. Find the length of each side and then the area of the triangle. Okay, so we're going to probably be using what we just did for the area, but let's see if we can find out all the sides. Okay, so how would we do that? Well, the only thing that we're given is we know that this angle right here is 50 degrees. Now, because it's isosceles, that means this angle is also 50 degrees. And because that is 50 degrees, I know that this, I guess, is going to be 80 degrees. Because all the angles have to sum up to 180 in a triangle. Now, these two sides are the same. All right, so what do I know here? I know this side, all right, right here. I know the angle. So if you know the angle and you know the side, now we know also this angle, I can actually use the sine law, right? So I can use the sine law to find out one of the other sides. So I can find out, for instance, this particular side. So what I'm going to use is, I know that, okay, so from the sine law, so I have sine of 80 degrees, okay, divided by, so I'm attaching it to the 10 centimeters, is equal to sine of 50 degrees divided by my unknown. So here my x, that side be x. You can do the opposite side as well because it's isosceles. And now we're just going to isolate for x. So x is equal to, this is going to be 10 centimeters multiplied by sine of 50 divided by sine of 80 equals, let's take a look. So 10 multiplied by sine of 50 and then divided by sine of 80. All right, so 7.78, so let's round it to 2 decimal places. So So it's approximately that much. And we know that both of these are identical. So this is also x because it's isosceles. So we have found, okay, the length of each of the sides. Okay, 7.78 centimeters. Now, in order to find the area of this, okay, so in order to find the area now, okay, so what we have is we have to know what this height is right here. And I can actually go back in here. So notice that area, so here's my, okay, so those are my A times B. So my base is 10 centimeters. Okay, so I can do that. Now, this A, so I know this is 7.78. Now, they're identical, so it doesn't matter which one you choose, because those are going to be the same triangles. So that's that. And then my angle, so here, this is my angle, which is going to be sine of basically 50 degrees. So your area is equal to 1/2 10 times 7.78 times sine of 50 degrees. Okay, so that's going to be this angle. So we're not going to choose this angle. You can't choose this angle because it would cut that triangle, right? So we want to be able to use the interior angle, which is the 50 degrees. So if we do that right here, then we're going to get our answer. So 1/2, which is 0.5, times 10 times 7.78 multiplied by sine of 50. And we have, so 29.8 centimeters squared. All right, so rounded to 1 decimal place. So that's another question, so question 6. And now for question 7, so right here, that's question 7. Maybe I'll take this little bonus there and talk about that as well. Okay, so we have, let me paste this in here. Given a triangle where the lengths of the 3 sides are 9 inches, 8 inches, and 7 inches, find each angle of the triangle. Okay, so we have 9, so that's going to be the longest. 8, so it's going to be a little bit shorter, I guess, something like that. And 7, well, that's going to be the shortest one. So this one, I'm going to try to draw it kind of proportionally. So it's going to be actually probably something, might look something like that. This one is 7. This one's 9, 8, 7. So we don't know, okay, what all of the angles are. All right. So we want to know what all of these angles are. And it's not necessarily a right angle triangle. So don't think that, you know, that it's a nice kind of a straight, it goes like that. Okay, we don't know that it's that. So it's going to be, looks like it's going to be some acute triangle because 9, 8, and 7 inches, okay, the way that you would have to structure that triangle, okay, would kind of force you to be acute. So the way that I drew it was actually kind of incorrect. So maybe I should correct this. This is not going to be more than the 90 degrees. So it's probably something like that in some way. So it's some acute triangle. Okay, so how do we actually find the angles if we only know the lengths of each side? Well, the answer is we can use the cosine law. So if you remember, so the cosine of an angle, now all I need really is just one of these, okay? So I can take the cosine of that angle, which is equal to, okay, so now this, let's see if you remember the cosine law. So I'm going to kind of write it out. So there's 2 ways of writing these cosine laws. Now this one is for the angle, so it's going to be basically, okay, so these are going to be the attached, so this is going to be 8 squared plus 7 squared minus the one which is opposite, which is 9 squared, divided by 2 multiplied by the adjacent ones to the angle. All right? Now, if we find this out, then we can take the inverse, so cos inverse, and then we know what the angle is. Once we have that one angle, then we don't really need to use cosine law anymore, because once you have one angle, then you can use just the sine law to find the other angle. And then the last angle, you can just find it by knowing that it's 180 degrees, right, for all triangles. Okay, so let's try this. Okay, so we have, so 8 squared, so that's 64, plus 7 squared is 49, okay, minus, that's going to be 81, this is going to be 32 all over, and then 2 times 8 times 7, well, 8 times 7 is 56, and 56 times 2 is 112. So now theta is cos inverse of 32 over 112. Okay, so cos inverse 32 over 112 equals 73 point approximately 4 degrees. All right, so that's one. So that's one angle. Okay, so now once I have this, okay, so what can I do? So I have this angle right there. So this is 70. 3.4, 73.4, and now let me use just the sine law. Okay, so I know this one and this one, so I'm going to just connect them back, and so that's going to be sine of 73.4 all over 9 is equal to sine, okay, I'm going to use this angle, so let's say this is theta 2, second angle over 8. Okay, so we can solve for that using the sine law. So let's see what that gives us. And so that's going to be, okay, so we have 8 multiplied by, so I'm just going to multiply 8 times, so sine of 73.4, and then divided by 9. So that's that. Okay, so we have all of that, and now, so this is going to be sine theta 2 is equal to, I'm going to, it's annoying, but I'll keep it anyways, 1, 8, 4, 2, 2, and so on. Now, what I need is, I need the inverse of this answer, right? So that's what I need. Let's see if I can, I'm going to clear this, so I need inverse of the answer. Cleared it for me, so 8, 5, 1, 8, 4, 2, 2. I know that we're missing some stuff there, but it's okay. So it's going to be 58.4 degrees. So that's this one. So now we have this and this. So I have 2 of these angles, and that means I can find this one. So now it's 180 minus 58.4 minus 73.4 equals, so it's approximately 48.2. So that's your last one. Now, if you like, you can use the sine law again or the cosine law to find that angle, just to double check. So it's going to give you that. Remember, we rounded, so it might be a little bit off, okay? But rounded, it should be that. And that was the last question, okay, on this one. And then it gives you this little bonus, okay, right here. So the bonus states, how is sine and cosine related to the slope of a line? Ah, that's an interesting point. Okay, so if you remember, okay, so if you draw, I'm going to just kind of arbitrarily draw here, and we have a line. So let's say this is a line. Now, if you remember, a slope of a line is rise over run. Okay, where we pick 2 points, okay, and we have a rise, which is rise, and this is your run, right? That was your slope. Rise divided by run. That's by definition is the slope of a line. Now, what do you notice about this? what you should notice is that whenever you have 2 points, okay, and you try to create this slope, it creates a triangle where your slope, so your slope is your hypotenuse, that is your slope, M, okay, that you're trying to find out, okay, within here. And so that hypotenuse, sorry, I'm going to write here H, hypotenuse, okay, so that hypotenuse with the rise and run, okay, can relate it back. So if this is your angle, so that's your angle theta, and remember, what is sine defined as? Sine is defined as, so sine of that theta is opposite over hypotenuse, correct? That's what this is. And then, okay, your cosine is adjacent, which is run over your hypotenuse. So look what happens when you take the sine, okay, and then the cosine, and look how they're closely related to your slope. Okay, here is your rise, here is your run. Okay, and you can divide them up. Okay, so by each other. So if you divide them, you're going to get rise, H. Now division means multiplication by the reciprocal. The H's will cancel. And notice you get your rise over run, which is sine theta cos theta. It's pretty neat. So now I know that for most people in grade 10, they may not actually go into this. It's a complete little bonus for you to kind of think about. And the reasoning is because this trigonometry and sines and cosines, as you keep going through math, you're going to notice that you can do a lot of magical things with them. Anyways, that pretty much completes my materials for grade 10. For those who actually lasted until here, and probably less than 1% will listen to these final words, but so be it. Hopefully it has helped a person or a student somewhere. Hope that you enjoyed those videos, okay? We'll see you in grade 11. Okay, cheers everybody. Bye.